Alright, hey guys. So, it seems like a lot of people are having issues getting started on this project Okaymon. So I want to kind of just go through everything and make sure everybody kind of has like the same base level understanding of what's going on. So right here, I've got pulled up the student preview, which is all I can really see as from the teacher perspective here. So let's just kind of go through everything like in piece by piece. Sorry, I'm going to move my mic a little bit closer. Um, all right, so Okaymon is going to be this knockoff Pokemon game, right? Um, and it's really watered down. It's just the fight sequence from a Pokemon game, basically, and using completely made up like monsters and all of that. So it says, all right, so let's just kind of go through these pieces one by one. So it says we're going to, this is going to be kind of a wrap up to Unit 3 functions. There is a little bit more to it than that because we got Oregon Trail coming up. But anyway, the goal here is we're going to have a little text-based version of a Pokemon-style turn-based fight. So you're going to have a bunch of starter code, which you've got right here, which is, there's a lot to go through, but you don't need to be concerned about too much of it. And so yeah, we're going to walk through all of this right now. So here's some kind of like a general breakdown, right? So we've got these different stats, and so this is very, very like watered down. So they just have an attack, or they have HP, so hit points, which is going to be an integer value, and if this value drops to 0 or below, the game ends. So that's a kind of key thing to keep in mind here, because remember, I don't know, say like your Pokemon has 3 HP, and they get hit by something that's super effective in normal, like in the normal Pokemon game, right? It's going to do a ton of damage, and they're going to drop not to just 0, but they're going to go way below. I think in Pokemon it probably just truncates it at 0, but in this you need to account for it. All right, so we've got a status, which is going to be a string value, and it can hold either confused or blank, confused, or stunned. So we're going to get to that later. Both of these Pokemon or Okaymon have a attack, which is going to be an integer. And that's the amount of damage a standard attack does prior to reductions, which are coming right up because they have armor as well, right? So this is another integer, and it just reduces incoming attack damage. Okay, so now we get to the status section. Okay, so there's blank, which means that they have no status. And like in a general Pokemon game, you've got all these different statuses that can happen, right? So there's like your Pokemon could be stunned, it can be confused, where it can attack itself. I don't know, like they can. I'm trying to even think back. I haven't played in a while. I don't know. What other statuses might there be? Like I can think of these in like a bunch of other like RPG style games where, I don't know, they could be like taunted or something where you guys always want to attack whatever unit's closest to them, or I mean in Pokemon they've got sleep, right? That's another status that you can have in the normal game, but we're only going to focus on these two. So. Right, so this explains here that confused is, or if an Okaymon becomes confused, it has a 66% chance to remain confused and a 33% chance to become unconfused. That actually gets handled later on for you. The only thing you were really concerned about in your code is going to be that, or actually, never mind. So getting to that, you're jumping ahead. So a confused Okaymon has a 50% chance to attack itself, a 50% chance to let you use it, or issue a command to it. Stunned is another status. When they're stunned, they have a 90% chance to become unstunned for their next turn and do nothing else, and a 10% chance to become or to remain stunned, meaning it cannot do anything that turn and is still stunned at the start of the next turn. So this is obviously like a little bit more powerful, right? A confused Okaymon is able to do a little bit more, so that way, or that's why, it has a little bit higher, or it has a little bit higher percent chance to stay confused because you can theoretically also still keep attacking throughout. There's just a 50% chance that you also might hurt yourself. Okay, so player one's Okaymon has 3 abilities. It's got attack, which is just some default attack. And it gives us a little formula here, right? So this game is making the assumption that you are going to be player 1 and your opponent is player 2, which is why the naming convention is a little bit weird. So it deals you attack, so player 1's attack damage minus the opponent's armor, because it's, you know, so if you use if your guy does like 5 damage and the other opponent has 2 armor, you're gonna just kind of or subtract that off. There's no fancy like, um, you know, like curves and percent damage reduction and stuff. This is just a flat out like this takes off the same amount of damage every single time. So there you go. There's a couple of functions that are given to us, which are getters and setters. We'll get to that a little bit later. That's pretty common in other languages. I don't know if Python uses those super extensively, but it's kind of a good concept to know in general. All right, so next ability here is Tortoise Shell, and this just adds 1 to your armor. So we can see over here, U armor starts at 5. So if they use this ability like the one time, the assumption is that this is going to jump up to 6, right? All right, then we've got Confusion Beam, and this is an ability that has a 50% chance to succeed. And so if it succeeds, and so this is basically, like we've done a bunch of these coin flip type things, right? So using random.random or random.random int to either choose 1 or 2 kind of a thing, or if random.random produces 0 through 0.5 or 0.5 to 1.0, then it succeeds, right? So that's what this is meaning. And then we use set status for this to give them a status of confused. And then the game kind of handles the rest, because these are the things that we're actually going to be coding. And then it should explain, you know, like obviously you're going to need some feedback. So if your ability succeeds, you want to know that it actually happened. Like in Pokemon, normally you'd have, like, you know, like a graphic would play or something. You don't just have to guess at whether or not your Pokemon's confused. And then yeah, obviously the same thing goes if it doesn't work out, you need to be able to know that the spell failed, or these aren't spells, these are abilities. I'm thinking of a lot of MOBA type games or arts, depending on which convention you use. All right, so player 2 has Okaymon, and same thing. You know, attack is going to just be a default ability that everybody gets. So that's going to work the same way. It's just kind of inverted, right? So instead of using U attack, it uses opponent's attack, and then it looks at whatever player 1's armor value is. Okay. Tortoise Shell is wrong one. Attack or tail whip, right? This is I think there's an ability from like Rattata or something in the OG, like red and blue. So this is going to reduce your armor, or player 1's armor, by 1. So that's another thing to kind of note here, since U is always referring to player 1. And again, sorry, this naming convention is a little confusing now. So I think originally I was planning to do it with like AI, but whatever. So anyway, it's reducing player 1's armor by 1. And then again, it's saying, you know, check out these set armor functions, okay? Lastly, we've got Earth Spike. So this is going to be his like super spell. So both of these guys kind of have the same set of things that just kind of do a little bit different stuff. Attack, they have a spell that modifies armor, and they both have something that's a chance-based ability. So Earth Spike has a 50% chance to succeed. So both of these kind of do the same thing, where they have a 50% chance to work out, and then for clearing the status, there's more stuff going on. But we're not going to be concerned with that, as we'll see in a little bit. And again, we're going to just use set status to set this. And once again, print out some sort of a message saying whether or not this thing is working. All right, so now we're going to get to the structure of the game. So it tells us, let's go down all the way to this area where it says run. Okay, so in here we've got this game loop. So each loop, this is doing the same thing, and this is all given to us. So while playing, so playing is just going to be a Boolean value that says, are we still continuing on with this game? So that means, you know, nobody's lost yet, nobody's won, nobody's quit. I think those would be the main conditions in something like this. Okay, so what this does is there's a command list, and let's see, up here, if we go to your commands, this is just kind of printing out, like, what are your options here? It's, you know, if you're just booting this up, you'd have no idea what you actually can do. So it's loading in the command list here. It's grabbing user input, and so we see this whole thing that says while not good input, and it starts out as bad input, right? So we're going to print what would you like to do. then we send them or giving them the commands list and then asking for input, storing that on command. These two here are just kind of sanitizing it, is what the programming term would be. So, I mean, if they gave us something totally goofy, like, here, let me just pull up. All right, so if I just pull up this and I say, you know, I want to, I don't know, I've got like caps lock on and then I forget halfway through and I say like that. All this is going to do is take whatever they gave us, and maybe there's even a space at the end. First thing it's doing, dot lower, is going to convert this all to lowercase. So everything's lower, and that way we can kind of compare these, because we'll see in here this command list is all in lowercase, and that way you can do a one-to-one comparison. Don't have to worry about like goofy casing, or you know, whether or not they have caps lock on, or if they're a very professional typer and they type everything with a capital letter first here because it's the beginning of a new sentence. Okay. Second thing here is strip. So strip is a string function, and it just gets rid of extra white space. So if this is their string here, strip just gets rid of this stuff. If they were to say something like attack my opponent or something like that, strip is just worried about leading and trailing white space, typically in most implementations of it. I think there's ways that you can usually modify this or ask it to get rid of all white space, but generally if you just call it with no parameters, it's going to get rid of either preceding white space or trailing, which would be on either end of wherever the first character starts. So yeah, we're going to just kind of loop until we get good input, because we don't want to move on until we get some command that the game recognizes. So we need to either see, you know, if player 1 is up, we need to see attack, Tortoise Shell, or confusion beam. If they try to type in tail whip or something, we don't want them to be able to do that, because their Okaymon doesn't actually know that ability. It's player 2's Okaymon that does. And that's why we're doing all this stuff up here, where we're loading in all the these command sets so that we have something to validate against. So this is some shorthand syntax. This is basically current commands is a list. So we can ask, is this command that they gave us in this list? If it is, then we just say, okay, this is good input because it was something we recognized. Otherwise, we can't recognize that. Try again. So once we get good input, then we need to do some immediate things where we're going to check what status they have, because if their Okaymon is stunned, we need to handle that. If their Okaymon is confused, we need to account for the chance that they issue a command and it attacks itself because it's confused. I mean, there's plenty of memes about that, right? It attacked itself in confusion. So that's what that's getting at. So in here we do a status check. This is another built-in function. So basically this one's going to return some things like it returns a numeric value based on what their status is. So every turn, this is handling all these things for us. So we go in here, it passes in what player. Get status is another, it's one of these getters and setters functions, which, where did I put these? There we go. So basically it's just going to return if the current player is 1, or we pass in 1, then it grabs player 1's status, which is U status. Otherwise, it returns the opponent's status. And because of how returns work, so if player 1 gets passed in, this checks and goes, okay, this is player 1, and it returns this. This code never gets hit, because once you return, that function is done processing. So this is going to just return whatever their status is. So if that guy is confused, it's going to return that, and that way we can kind of work with this. And it's just handling a lot of that for us. And we'll see in here, all the stuff that we covered about global scoping and things is covered in this. So, you know, when you're just accessing stuff, you don't need to worry about using this global keyword. That's why it's all commented out here. But over here, when we're setting it, we do need to worry about it. And actually, I think, looking back, this is not the way to do it. You can, I think, just comma separate all of these, but yeah. Just goofiness on my behalf. All right. So this is checking to see. So we grab their status. Whoops, I just collapsed that. Whatever status, blah, blah, blah. 90% chance to become unstunned, 66% chance to hit yourself, This is just using random.random, checking different percentages, right? So we have a bunch of different values, and it gives us a little bit of heads up here in the comments saying what these do. So 1 is you can issue a command. 2, if you cannot, so that's basically saying that you're stunned or whatever. And 3, if you attacked yourself. So let's go back down here. All right, so we're grabbing all of these guys' commands, blah, 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 figure out if they can issue a command. So if they have a status of 1, which means that they're good to go basically, then we can let them do their turn. Otherwise, we check to see, like, if the status is 2, they're stunned, right? So they can't do anything, so it doesn't really matter. And then this is excuse me, checking to see if status is 3. And so this is they basically rolled the dice, and they're going to attack themselves. And we can even see here how this gets implemented, right? So this is using set HP, which is a setter for whatever the current player is, and the toggles every turn, which we'll get to kind of a little bit later. So every turn this toggles. Player 1 can set their, or if it's the current player is 1, then we go and do player 1's turn. And this is something that you're going to be implementing. Otherwise, we're going to do player 2's turn, and we're going to pass them that command, which is going to be a string value. But yeah, so otherwise, we're setting HP to, and this takes in a couple of different things. It asks who the current player, or what player we want to modify their HP for. So current players, like who are going to, if current player is the one that's stunned or confused, they're going to be hurting themselves, right? And then we pass in what new value we want, and so this is calculating this. So we grab the HP of the current player, and then we're subtracting out whatever damage they would do, and because this is a monster that's attacking themselves, we're grabbing current players' attack damage, and then we're subtracting off their armor because it's reduced by that. So if you use Tortoise Shell a bunch of times and attack yourself, it gets reduced. And then because of these parentheses, this part calculates out first, and then we subtract that, or then we're taking their current HP, subtracting off whatever gets left after reductions, and storing it into that, which is what set HP is going to end up doing. All right, so one of these guys is going to have their turn, and then we check for the game state, and I think this is another one that we're going to have to implement. But yeah, like if the game is still going, then we're going to keep toggling players. But if somebody has, and basically the game state comes down to, I think, if it's returns, what is it, like 1 if player 1 won, it returns 2 if player 2 won, and it returns 0 if the game is still in play. So this is checking to see basically, is this 0? If so, we're going to swap players because this is a turn-based game and the next guy needs to get his chance. Otherwise, playing gets set to false, and remember this is what's driving our while loop up here. So this keeps going like while the game is in play, and then we're going to just print out who the winner is. At the end of each loop, we need to print out some status basically. So afterwards we want to know what everybody's HP is at, what their armor is, what status they have, and so forth. And then these two guys down here are just calling like a init, I think just does some stuff like, yeah, prints out welcome to Okaymon, and then game loop starts out. Okay, so this tells us a little bit about what's going on in the game loop. So this is kind of the pseudo code version of it. We've got show the player their options. So, because we're giving them the command list. We're going to loop until we get valid input. We're going to do whatever the player selected, if they can. Check to see if we can keep playing. And then we are going to print the game state to the player, or so that the player knows what's going on. So now we have this last piece here, which is the to-do. So important note here, all of your chance-related code should be specifically using random.random. Otherwise, you'll fail the automated tests. And this is because the way that automated testing works, like if we need to test things that are random, we need to make sure that it's hitting certain things. So the way that things are working on the backside of this is that we can basically, when we see the code calling out to random.random, we can catch that basically and then go, no, 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 don't actually execute this code. We're going to return whatever this value is so that I know what it is and I can validate that your code is doing the same thing that mine is. Otherwise, every time you call random.random, you're going to get different values, and we can't see that the outputs would have been the same. So that's why that this is specifically asking to use random.random. This important note too is that we need to comment out game loop. This has to do also with automated grading. It's goofy because it gets kind of caught in here because the automated grading doesn't actually play the game. It's just testing out various functionalities. It's more to do, I think, with REPL than Python's unit test framework, but that's why these are the two important notes. Is it breaks grading basically, so you can't see you can't run your code against the grader and see what is actually working and what's broken. Okay, so last thing here is, let's see, you need to implement 3 functions. So it tells us we need to do check game over, and I think is this one given to, so yeah, this one's kind of skeletoned up here, and it tells us what the different return values are. So you're gonna need to be able to check, like, did somebody win, and again, to figure out if somebody won is where is that? Somewhere up in here, basically, is if hit points drops below or is 0 or below, the game ends. So that's going to be part of this entire thing. We're going to need to implement player 1 turn, and this is taking in a parameter that represents player's selected command choice, and then based on whatever that command was, it executes the logic for the ability. And so those are all described up in here. A lot of these are pseudo-coded out for how you might handle it. And of course, you have kind of an example to look off of down here with how a monster attacks itself in confusion. And then basically the same thing for player 2 turn. So I'm going to show you an example of how this runs. So we get our init function runs, and it just says, welcome to Okaymon, what would you like to do? So I'm player 1 at this point, because it's always going to start on the same player. So let's just start out with some of these basic things. So I'm going to use Tortoise Shell. Okay, and so I see here that, well, it's hard to see because I don't know what my armor started out as, I guess. But it went up by 1. And this one's asking now, I'm player 2, and we've seen that it loaded in the command set for player 2. And so I'm going to use tail whip, and this should just reduce this guy's armor, right? So, and we see that player 1's armor did indeed go from 6 back to 5. All right, so now let's try out some of this other functionality here. So I'm going to do attack. So what I should see here is that player 1's attack damage is 5. Player 2 has 2 armor. So theoretically, this should do 3 damage, which would leave us at 42 HP. And that's precisely what happens here. So same thing. So player 2, they started out with less HP, so their guy does more damage to kind of balance that out. And this guy has 10 damage that he does. And then, let's see, so this guy has 5 armor, so this is going to do a grand total of 5 damage. So if this guy has 66 HP, after reductions, then this is going to relieve us with 61 HP. So let's attack, and there we go. So let's also see what happens if we do some weird input, right? So I'm going to leave, whoops, I'm going to put a space in here, and I got, whoops, got caps lock on. I'm going to say attack. Oh boy, I really want to kill this guy, right? So there we go, and we can see that it did all the sanitization and it recognized what was going on here, even though I have weird space beforehand, space afterwards, and this is in all caps, even though that the attack in here is all lowercase. And that was what I was talking about, where it's converting everything to lower and then stripping all the white space. Okay, let's see how some of these other things work, right? So I'm going to do Earth Spike. So again, this has got a it's like a 50-50 chance, right, that this is going to actually work out. And if it does, they have a 90% chance to be cleared after one turn, and a 10% chance that it's not going to clear. So in here, you stunned your opponent, so my 50-50 chance worked. And we can see now in here that this guy now has a status of stunned. So we're going to go, and I'm going to try to use Confusion Beam, but I think it should deny me. I became unstunned, and I confused. So that ran a little bit weirder than I expected. Probably poor coding on my behalf. But yeah, so they became unstunned, and they confused their opponent. So now my status is cleared this turn, and my opponent actually gained confused status. So let's just keep playing with this a little bit. So I'm going to Earth Spike this guy again. I don't know what this spelling is. You are still confused. All right, thank you. You hurt yourself in confusion. So this guy does considerably more damage, right? So the last turn, this guy was at 39 HP. And then he did, because he's attacking himself, it's using his attack damage of 10 minus 2 armor. So that's a grand total of 8 damage. So we do 39 minus 8, and that's how he results in 31. So I'm going to just kind of keep attacking both of these guys until the very end, until somebody wins. Man, this guy is still confused. Holy crap. Oh my goodness, that took a long time to clear that status. So player 2 is not doing too hot here. Player 1 is still cranking, right? Just do this again, attack. And we can see that the winner is player 1. Player 2 dropped to 0 HP. Did that do perfect amount of damage? Is that what happened there? Yeah. Okay, so that's why. So that was, unfortunately, we didn't get to see it drop into negatives, but this would have worked if it was negative either, or as well. So that's kind of like the gist of what's going on in Project Okaymon. You've now seen an example run, and we've kind of gone through the code. This took a lot longer than I expected, but there we go. Hope this helps, and keep cranking out there, guys.